The function t of h equals the square root of h divided by 4 9/10 represents the time t in seconds that it takes for an object to fall a distance h in meters due to the Earth's gravity. Two divers jump off the face of a cliff at different heights but at the same time. Diver number 1 dives from an unknown height, and diver number 2 dives from a ledge of several meters higher than the first diver. If diver number 1 hits the water at 2 and 203/10,000 seconds after jumping, and it takes 2,832/10,000 seconds longer for diver number 2, what were their heights on the cliff? Use the graph to determine your answer. Okay, so in our function here, remember that t of h is going to give us the time that it takes for the object to fall a distance, and the distance is h. And so if it gives us the time, then those are things that we could substitute in for t of h. And so for diver number 1, then for t of h, we could substitute in 2 and 203/10,000 into our equation. And then for diver number 2, it takes an additional 2,832/10,000. And so we can just basically add that, to the first diver's time, and that will give us 2 and 3,035/10,000. And so we can use that for our second equation and sub that in for t of h. So having that, then we can just use a calculator to actually solve these. So for one, we can just type in diver 1's time here into y1, and we can type in diver's 2 time into y2, and then we'll just put the function into y3, and that way we'll have 3 lines and we'll be able to see when does y1 and y2 intersect with y3, and then we'll have the two different distances there. Okay, so in my y equals menu, I've gone ahead and I've typed in my y1, my y2, and y3, and I used x instead of h, and then we can go ahead to our graph. So in our graph, it seems like we need to zoom in a little bit and then also go out farther on our x-axis to be able to see where this actually intersects. So I'm going to go to my window, and we aren't going to have a negative x value. So, and then my maximum, I'll just say that goes up to 50, and then for the y minimum, I'll put 0, and I'll have that actually just go up to 4, since we know those times are, only at 2. So I'll hit graph again. Okay, so now we have a good view of these graphs and where they intersect. And so let's go ahead and find diver 1's time here, which will be the first line intersection with our curved line. So I'll press second trace, then intersect, and then I need to go to the left of that intersection, press enter, and then go to the right of it, and making sure to be on the line that is curved, which is our function square root line there. Press enter and then press enter again. And so for our first diver, then we have an x, or in other words, the distance that they jumped was 19.9999899. And so we could round that up to 20. So he jumped from about 20 meters. And then let's go ahead and find diver number 2's distance. So again, second trace 5. And this time we need to hop up to the other line, so you can just press the up arrow. So I'm on the curved line now. I can press enter because I'm to the left of that curve, and then now press up again, twice actually, so that I can get to my diver number 2 line, that straight line up there, and then press enter, and then enter again. And we see here the intersection is 25.99995. So rounding up there, that'd be about 26. So diver number 2 is going to jump from about 26 meters. And so we have our two answers. Let's go ahead and summarize. The graph shows intersection points for the function t of h equals the square root of h divided by 4 9/10, and the equations y1 equals 2 and 203/10,000, and y2 equals 2 and 203/10,000 plus 2,832/10,000 equals 2 and 3,035/10,000 at 19 and 9,999/10,000, 2 and 203/10,000, and 26, 2 and 3,035/10,000 respectively. So diver number 1 jumped from about 20 meters above the water, and diver number 2 jumped from 26 meters above the water.